Hello, it's Macy, and today I was going to talk a little bit about the Significance Manager plugin that's been in the engine for a while, but documentation is kind of lacking for it. Um, I'll just talk really briefly about what it's about, what you can do with it, and I'll also show you some code, a bit of an example project. So let's get right into it. Alright, so what is the Significance Manager? It's a very abstract plugin that allows client-sided optimization. And it really is just a framework where you can register certain type of objects in these significance buckets. So an object that's registered in the manager has this significance value. And then based on the significance value, you can then specify certain things that you can do to that actor. For instance, reduce tick rate, disable smoothing, or anything that you can come up with that will optimize your game, such as also disabling cosmetic events and stuff like that. And as I said, these optimizations has to be implemented by the project. The plugin is just a framework that allows you to register objects and then determine a significance and then act on that significance. So determining significance and then what to do with that significance is something that you'll have to decide yourself for your project. So it really is abstract in that way. And an example that you can do, um, probably the most basic example for any sort of first person or third person game, is that you can determine significance based on distance, which is probably what you should be doing. Then you can also, if it is a player, then you can determine significance based if the actor is in view or not. So I made this really basic chart. In the center we got our own player. These smaller dots are other players or other actors, to say. And here we have our significance values. So highest significance is green, lowest is red. And if our own player is obviously going to be green, then if it's within 50 meters and it's inside of our view, as we can see by this slice here, then it has a very high significance. But once we start getting further away, the significance gets lower and lower. And it also it gets more lower, it gets increasingly lower, whether or not if it's in view or not. So if it's not in view, it gets lower. If it's not in view and it's the same distance as another actor that is in view, it's gonna have a lower significance because it's not in view. And it also supports particle systems. So it's already built into the significance manager with the particle systems. So particle systems will not tick or activate even if the significance level is not high enough. And you can invoke this function, so required significance, on a particle system component. And then here's the particle system editor. And it has a required significance value here, which is the significance value that's required in order for this to spawn. And of course, you set that here as well. Some basic API, it's registering objects, which is basically what you're gonna do per actor. And so you basically, this is where you assign an object and you plug it into the manager. And then the manager can do all of its different, can determine significance and then act on that significance. So it's gonna take in the object, it's gonna take in a tag, which is, so you don't have to cast because these managed object significance functions, they have the object, they have a tag, and then they have the significance value. So instead of having to cast a U object when you try to figure out what it is, then you can just do it by the tag. And it has a post significance type, which is whether or not you should run this post significance function concurrently or sequential. If you do want it to run concurrently, you have to make sure that the contents of this is thread safe. Then we can also unregister the object from the manager. And another important function is this update function, which is going to take in an array of transforms. This is basically your different viewpoints. Most likely you're going to want to call this function every single frame. And I'll show you guys how to do this as well. Basically, if you're running split screen, I think you probably want multiple one of these transforms. But for most cases, you only want one, which is going to be your viewpoint for the camera. And what this function internally does is that it iterates through all of these different viewpoints, then iterates through each one of your registered objects, and it then calls the significance functions, the get significance function, and then the post significance function. Obviously, depending on if you want to do those asynchronously or sequentially, which is what you define here, as I said. Then we can query and get our significance for a function. So this one just gets significance for the function. This should be a float, should not be a void, so just be aware of that. Then we can query our significance, which internally checks whether or not the object has been registered, which is the first return value. Then it returns the significance if it has been registered. You can also write your own custom significance manager. You can register, you configure it by going into your default engine, the INI, and specifying your own custom significance manager class if you wish to extend the functionality that's already provided. So there's some great talks that Epic did on optimizing UE4 for Fortnite, where they use significance manager quite a lot in there, and they go over quite a lot of the techniques that they plug into the significance manager. There's also the official docs. But what I'll do now is I'll actually open up a project and I'll show you guys how to implement a very basic implementation of the significance manager into a real world example. Right, so here I have a very basic, it's just a third person template project. I've just set up this map to sort of visualize the different distances. Because the first thing that I'll show you guys is how you can determine significance based on distances. And what we'll do is we'll reduce the tick rate of the character movement component based on that significance. So it's kind of clear what's going on. But the first thing that we're going to have to do is enable the significance manager plugin. And I believe in 4.22 it is already enabled by default. And what we're going to do is we're going to add a game viewport client. So if you remember, there's this update function that you have to call. Most games want to do this every single frame. Specifically shooter games and stuff like that, you want to do this every single frame, as things tend to pop in and out of view. So we'll create a new game viewport client. And we're actually going to be doing this update call and the tick of this game viewport client. And this is only client-sided. It does not exist on a server. And while this is compiling, it's actually already done. We're gonna have to go into our build.cs, and in our dependency modules, in the public dependency module names, we're gonna have to go ahead and add the significance manager module into here so we can actually compile. Okay. And if we now go into our demo game viewport client, first thing that we're going to do is we're just going to implement a constructor for this. I like to use the U class body, as it automatically generates a constructor for us. Right, and if we switch back, we can override our tick function. called the super. And we'll go ahead and include our significance manager. It's just significance manager.h. And so if we go into our update function, remember it actually takes an array of different viewpoints. The viewpoint that we're going to be using is the player camera viewpoint, which is basically what's being rendered on the player viewport screen, and we can access that using the player controller. But since this is tick, it's kind of inconvenient to try and access the player controller every single tick, since we most likely have to do on iterator, since there's not really any references in the game viewport client. So we'll have to iterate over that, and in the gameplay statics there is already a iterator that does this for us. But we're gonna cache the player controller, so we only have to do this iteration once, as iterations are kind of expensive. But we'll go ahead and include our gameplay statics, and we'll also include our player controller. Right, and then if we go back, we're going to create our variable for our cached player controller. Make it protected, and we'll make it a weak pointer. Okay, and if we go back now to our tick function, the first thing that we're going to do is make sure that our world is valid. Don't see why it would not be valid, but it's always good to check your references, check your pointers. Alright, and then what we can do is we'll create a variable has valid data, and this is just going to go get our cached player controller and check whether or not it is valid. And if we do not have any valid data, we're going to go ahead and get the player controller pointer, which again we do with the gameplay statics. So player controller tc equals cast. Actually, we don't need to cast, we just go gameplay statics, get player controller, and pass in our world and index 0. And player controllers, once again, are only valid to the local player. They're not replicated to other clients, so index 0 is good enough. Or it will always just return the player controller that this game viewport client is using. And then we can assign this player controller that we just got to our cached variable. You can actually just assign it like this, but I like to do actually specify the type as well. Make it clear that it is a weak pointer. Alright, now we've assigned this, and presumably this should now be valid, but even if it isn't, we will make sure that we only run all of this code based on if we have a valid data. Because this could just return null for all we know. So we'll just keep doing this on tick until we eventually find a valid player controller. Okay, now we can actually go ahead and get a instance to our significance manager. We do that by accessing the significance manager module, and we can get a pointer from there. Just pass in our world, and there we have a valid instance. Well, if it's not null, at least. Alright. once we've done that, we can actually go ahead and call the update function. As you can see, it takes an array view of the transforms, which is basically just a normal array. And yeah, as you can see, you can actually specify multiple viewpoints. I don't see why you would need multiple viewpoints. Maybe if you're running split screen or something. But for most cases, you're only going to need one viewpoint, which is your actual camera viewpoint. And let's actually get the camera viewpoint as well from our player controller. So we're going to create a vector of the view location and a rotator of our view rotation. And we can get our cached player controller and get player viewpoint and pass in our variables. And this internally just gets the player camera manager and then gets the location and rotation of that. Then we can actually add a new we'll do pace, so we don't actually have to create a new transform. There we go. And this should be all that we need to do for our game viewport client. So just to recap, we get a valid player controller instance. From the player controller, we can get the viewpoint of our camera, and we then call the update function with that viewpoint. And that update function is going to call for all. It's going to iterate through all of our registered objects, and it's going to then determine significance for them, and then act on that significance, which I'll show you how to do next. Actually registering an object. But before we do that, we're going to have to go into our config. And if we go into our default engine.ini, what we'll do is we'll specify that we're using a custom game viewport client. So we'll go game viewport client class name, script, and our game module name. And that's all you have to do. It's complaining about the world, so we'll just include the world here as well. Alright, we'll go ahead and build this and make sure that nothing is broken. Meanwhile, we can go into our character and we're actually going to register this character. I'll show you how to register this character into the significance manager. And to do that, we're going to need two functions. It's going to be one function, which is the significance function. It gets the significance of this object. It just returns the significance. And we're going to have a post significance function, which can either run concurrent with the first significance function or sequential. Basically, this function, it just acts on the significance that's just been assigned. If you do decide to run it concurrently with the first function, you have to make this thread safe, the contents of this function. I usually don't run it concurrent, I run it sequentially. And it'll actually be a argument that you can pass into the register object function in the significance manager. And you can specify if you want to run this concurrently or sequential. If we go into the significance manager, if I can spell that. Go into the header of that file. There is a function called, well, the functions that we're going to use are these managed object significance function and managed object post significance functions. It's a T function, which means that you assign it with a lambda, but I'm actually going to wrap a function inside of those lambdas to make it easier and more cleaner to actually understand what we're doing. So we're going to need these different functions. I'm just going to drag this to my second monitor. So, all right, we'll create some space here, and we'll create some functions for those. All right, so the first one's going to be a float, and it's going to be our significance function. And it's going to take a significance manager f managed object info, which is going to be object info, and this just stores the actual object reference or pointer, and it has the tag and the significance value that that's been assigned to it. We're going to have a transform, which is going to be our viewpoint that's currently being iterated over. As I said, you could specify multiple viewpoints, so it's going to iterate through all of the viewpoints that you specified in your game viewport client. It's then going to determine significance for each one of those, for each of your registered objects. You can have another function, which is the post significance function, and it first argument is the same. The second one is going to be our old significance. New one, the second float is going to be our significance that's currently assigned. And lastly, a boolean, whether or not this is final. Also, we're going to have to include our significance manager in the actual header itself. All right, can implement these. Move these to the bottom. And this one will return 0 for now. All right, and then we're gonna have to create a begin play. And in here, we're going to register this character to the significance manager. Should we call super on that? And make sure that we're not doing this on dedicated servers, since this is pretty much client-side only. And here we're gonna have to access our significance manager, which we do exactly the same as we did here. We get the module and then we get a reference from there. Okay, and then we can call our register object. We pass in this, and then you can specify a tag. Now a tag just means that, so you don't actually have to cast between the types to find out what it is that you're trying to handle. You can actually just determine what it is by a tag. So you don't have to do any sort of casting there. So for this, I'll just specify this as a character. And then we have our managed object significance functions. It's these are lambda, so you can't. I haven't really found a way that you can actually assign a function directly to one of these. I found that you actually have to specify lambda, so I'll just create a lambda for this. And I'll wrap our functions that we created inside of those. It's actually a float, and it has to be the same arguments. Okay, and we can pass that in. And here you specify whether or not you want the post significance function to run concurrently or sequential. I run it sequential, as I said before. If you do run it concurrently, as I said before, make sure that the contents of this post significance function is thread safe. Then we're gonna have to create another lambda for the second function. And we'll pass it in. Okay, that's how we register our objects into the significance manager. Once again, in this function, you determine significance of the object, and then here you act on the significance that you determined in the previous function. So, as again, we use the tag. So, if object info get tag is, in this case, it's going to be a character. You can then get, since this managed object info actually just stores a U object, we will have to cast the type once we know what to cast to based on this tag that we have. Okay, and then we can actually get a distance between our viewpoint and this character. Since I'm gonna show you first how to, I'll show you a simple example of how you can actually determine I'll show you a very basic way to do this. I'll use an if statement for now. I'll show you a more advanced or a better solution for doing this, so you don't have to do a whole bunch of if statements for these. But this will do for now. So we'll get distance, actor location, subtract from the viewpoint, get location size, and that's our distance. And let's say if our distance is greater than, for now we'll just do 10 meters, we'll return no significance. Otherwise we'll just return a significance of 1. So that's a very basic way of assigning significance. As I said, I'll show a better way of doing this instead of having to do a whole bunch of statements. Make sure you also put a default significance. Right, and we can do the same thing in here. We can get our tag, can cast, and then what we'll do is we'll do something that really shows that we're outside of significance. For now, we'll reduce the tick rate of the character movement component, so you can actually notice a bit of jitter when the character moves outside of the significance range. So to really just illustrate that something is happening. And for players that are really far away from you, in a real world example, you probably do want to reduce tick rate if you can't even see them, or if they're really far away, as it doesn't really make a whole lot of sense if they should be updated at a really high quality. And we can get so we'll get our significance, and if it's 0, otherwise we'll go character movement, set component tick interval to 0, which is every single frame if it does not have 0 significance. Otherwise, we'll set it to 0.5. Should be really noticeable. Right, so we'll build this, and I'll close down the editor because I don't really like hot reloading. I like to build fresh binaries. Yeah, so I'll show you guys what this looks like in the editor once that's been loaded up. Right now I've loaded up our editor. If we go ahead and play with two clients and a dedicated server, and put these right next to each other. Go ahead and I've marked these with these different, as I said, I've set up the map so it has these distances. So right here is 0 meters, and if we go and play with our second client, once we reach that 10-meter mark, you should see starts to cut out. And if we go back in, you can see that it's reverted our significance back to the normal level. It's taking a bit to update because we're updating the tick rate kind of slow, so it's a 0.5 second delay when we walk in and walk back, as you can see. Right, so that's a very basic way to set up the significance with these if statements. I'll show you guys a better way to actually do this. If we go ahead and close the editor, I'm going to remove this entirely. I'll show you how you can actually set this up in a better way. So if we go into our character, what we're going to do is we're going to build the sort of list of different significance levels. We're going to build a list of distances, and then we're going to have a significance level assigned to them, sort of like a map. You could use a map, but I'm going to do something a bit different. So what I'll do is create a struct. We'll call this significance settings. Just have a variable to that. So this is going to store a bunch of data for the significance manager to use, or for these functions to use for the character. And I'll actually create another struct. We'll call these significance thresholds. And in here we're going to have a float called significance. We're going to have another float called max distance. And the idea is that we're going to have a maximum distance at which this significance is applied to. And we'll create a constructor for this. Right. And we can create a array of our significance thresholds. I'm actually going to use the allocator for this. With 4. Actually, let's use 3 for this example. So these are our thresholds for the significance. And the idea is that you can have a whole bunch of different settings in here, not just these distance thresholds. So we'll create a function here called get significance by distance. Pass in our distance. And that's just going to return what was set in these significance thresholds. And so the first thing that we're going to do is check if our distance is greater or equal to the highest distance in the threshold, which is going to be our last element. We'll do messenger of significance settings, thresholds.num, and we'll call this num thresholds. So if it's greater than the max distance of the last threshold, or the highest distance that our threshold allows, then we're simply just going to return the significance of the last one that we'll define in our thresholds. Otherwise, we're gonna have to iterate, and we'll turn 0 here at the bottom just in case, but it should never happen since we should have basically cleared out that case right in here. But yes, we'll have to iterate. We'll have to do a for loop. And in here we'll just check all of the distances, whether or not they match inside of one of our threshold settings. Create a variable for this. And if the distance is less or equal to the max distance of the current threshold, then we'll return the significance of this threshold. And that's that function implemented, and then we can actually go ahead and put these in our significance functions. And here we'll actually have to kind of do the same because we only really have we only really have 3 significance levels. So we can actually, and we can do an if statement here. I think it's okay. Again, as if we were going to avoid if statements, but I think it's fine in here because we'll only have maximum 4 significance levels. And in our case, we only have 3. So, all right. And if we have the highest level of significance, we can go character movement component tick interval 0. Then we can gradually sort of throttle the tick rate. Put this here, and then put this at 0.25. All right, and we should be able to go ahead and compile this now, and we should have an easier way of determining significance instead of having to use all of these if statements in here. And again, just a tip is that you might want to have to move all of this into an interface, because you basically have to do this for every single object that you will register in your significance manager, which is not really ideal. So what I'd actually suggest you do is you move this into an interface of some sort. Right now, let's actually go ahead and put in some significance values. So if we go into our constructor, can go get our significance settings, get our significance thresholds, and we can unpaste. And what we'll do is highest significance, which is going to be 2, 0 based. And the max distance for this is going to be 1,000 units. We'll have 3 different significance levels as defined in our allocator. 0 and 1, and we'll do this 25 meters, and the highest one 50 meters. So in order to have a significance level of 2, you have to be closer or equal to 1,000 units. In order to have significance level 1, you have to be closer or you have to be higher than 1,000 units, but less or equal to 25,000 units, or 2,500 units. And the same goes for the last one with the lowest significance. And we should now go ahead and start up the editor, and I'll show you guys what this looks like in editor. So here we have the editor, and we'll go ahead and launch this. And I'll show you guys what this now looks like. Go ahead and move to our starting position. Once again, when I move really close, you can see updates really nice and smooth. When I go beyond 10 meters, you can see that now we'll start throttling. If I go even beyond 25 meters, you can see it's really jittering. If I move back closer again, see now we're back to sort of like a medium update rate. Then we go closer, and then it's back to smooth again. And obviously you don't want this super aggressive throttling this close. You want to do these maybe at 2,500 meters or 25 at 2,500. Okay, not 2,500. 250 meters is probably where you want to do this at, but just for this demonstration, I've made it super close distance, just to really visualize how you can optimize your game by sort of throttling stuff, removing stuff when it's not really necessary. So that's sort of like a very brief, simple tutorial on how to use the significance manager. I know I didn't really get into, so you can really extend this to anything really in your project. It really is determined by what your project needs. And this is just a very easy demonstration of how to actually utilize this framework. As I said, you probably don't really want to do what I did to just lower the tick rate. So example, if you have some sort of cosmetics that play, you might want to disable those for low significance objects. Maybe disable network smoothing and stuff like that for really far away players. So it really comes to you what you want to do with this system. And really what I just wanted to do is show you guys how you can use the system. And it really is up to you what you do with it. So but yeah, it's a pretty good, it's a pretty neat plugin that you can use for optimizing your game. And yeah, if you guys have any questions, make sure you post them in the comments. I will try and do my best to reply to them. I've been kind of busy lately, but yeah, I'll do my best to reply to them. And I think this code should also be up on GitHub if you guys want to download this project. By the way, thank you guys for watching.